Keeper 1.3, rational form of integration. All right, so we just need to remember some of our rules, again, from last semester for our rational form of integration. If your degree of your numerator is greater than the degree of the denominator, we want to use long division before we integrate. If the degree of the numerator is equal to the degree of the denominator, you can use long division, or you may be able to add quote-unquote 0 to simplify the integrand. So adding 0 is not necessarily like literally 0. It could be like adding 1 minus 1, or adding 7 minus 7, or something like that to make it a little bit easier. If the degree of your numerator is less than the degree of your denominator, then you want to try to use partial fraction decomposition to simplify. All right, so for example 1, we have the integral of x minus 4 over x plus 3 dx. And again, I can use long division here, or I can simply go ahead and add 1, add 0 to simplify my expression. So instead of doing long division, I added 3 minus 3. And I'll show you why I did that in 1 second. So again, I added 3, and then I also had to subtract 3 so that I'm not actually changing my equation at all. All right, so when I do that, I end up with x plus 3 minus 7, and then I can separate my denominator to both parts. So I have x plus 3 over x plus 3 minus 7 over x plus 3. X plus 3 over x plus 3 is simply 1, and then so I have 1 minus 7 over x plus 3, which then I can integrate to be x minus 7 ln x plus 3 plus c. So again, that's like a new little technique I'm showing you guys. You could have used long division if you wanted to, but sometimes it's just a little bit quicker just to add the 0. And the 0, again, I'm pulling that from what my denominator is. So since my denominator was x plus 3, my goal was to make x plus 3 happen in my numerator as well. And so that's how I knew to add 3 and subtract 3 to get my 0. All right, so the next example, example 2, we have the integral of 3x minus 4 over x squared minus 5x minus 6. Since my denominator is bigger and it's also factorable, I'm going to use partial fraction decomposition. So I'm going to have the denominator, I'm going to factor that to x minus 6 times x plus 1. Set up my partial fraction decomposition to be a over x minus 6 plus b over x plus 1. So I have ax plus 1 plus bx minus 6 equals, remember your partial fraction always equals the numerator of your original function. So 3x minus 4. If I distribute my a and my b in, I get ax plus a plus bx minus 6b equals 3x minus 4. And then if I go ahead and set my expressions equal, so in other words, everything that has an x, I'm going to set those equal, and then everything that's just constant, I'm going to set those equal. So I have a plus b, since that's the two x terms on the left, equals 3, since that's the x term on the right. And then I have a minus 6b, which are my constant terms on the left, equals negative 4, which is my constant term on the right. All right, so then probably the easiest way to do this is just to subtract the two equations to cancel out my a's. So when I subtract the two equations, I get 7b equals 7, or b equals 1. Now, if b equals 1, then a must equal 2, because the first equation we had was a plus b equals 3. All right, so that gives us the integral of 2 over x minus 6 plus 1 over x plus 1 dx. And then I can integrate that, and I get 2 ln x minus 6 plus 1 ln x plus 1 plus c.